So at this point we have APIs exposed, we saw the basic authentication in action and all the necessary dependencies that we need to create and work with JWT tokens in Spring Boot. So it's finally time to learn how to create JWT tokens. As the first thing we would like to do, let's navigate to resources, and right here we can delete these two empty destinations, templates 2, and the first thing I usually do, I change the extension of application properties to application.yaml. Of course, it depends on what you prefer most to work with. I prefer to work with YAML files as I believe they are a bit cleaner way to do the same as the application properties. Right here we'll specify three things: the access token expiration, refresh token expiration, which we will use later, and the key used to generate JWT tokens. So I would like to start with JWT key, and this value in real life scenarios should never be put and hard coded. So I would like this to be sourced as the environment variable. Later I will show you how to populate that. The next thing I would like to do will be add access token expiration. Access token expiration key. And this value will be in milliseconds. So right here I will specify 3,600,000 as the value. 600, 1, 2, 3. For the refresh token expiration, I would like to specify 86,400,000, which will be the equivalent of 24 hours, if I'm not mistaken, in milliseconds. 86,400,000. 1, 2, 3,000. Excellent. So again, the most important thing is you should never hard code your key inside the code, unless this is some testing, of course. As the next step, let's make use of these properties and let's introduce class annotated with configuration properties. So let me go right here, new package, and call it config. Nextly, let's introduce the JWT properties data class. Kotlin class/file JWT properties. Excellent. And as I mentioned, we must annotate that with configuration properties. Configuration properties. And let's specify JWT. In a moment, I'll explain step by step what it does. The first thing we would like to specify here will be the key, string value, val access token expiration in long, val refresh token expiration, also long value. So if you would like to learn more about configuration properties, then in the description for this video you will find the link to my other article. But long story short, whatever we put here as the keys will be mapped to this object. So Spring Boot will instantiate a new singleton with values populated from our configuration. This approach is really useful, and in the future it can be easily extended by adding new keys. Nevertheless, the next thing we must do will be adding a configuration class in which we enable that. So let's click right mouse button on config, Kotlin class, configuration. The first thing will be the configuration annotation to let Spring know that this class contains the configuration, and the second one will be enable configuration properties, which will basically enable the class we implemented and allow for this feature to work. Enable configuration properties, and we must specify the exact class, so properties class here, Ctrl+Alt+L, wonderful. As the next thing, I would like to introduce the TokenService, which will be responsible for generating JWT tokens, validating, extracting claims, checking whether tokens are expired, and things like that. So let's click on the service package, right button, Kotlin class, and let's name it token service. This will be service, so again we must annotate that accordingly, and let's inject JWT properties. JWT properties. Excellent. So as the first thing we need to do will be create the instance of secret key, which later will be used to sign the token. So you may remember that we sign our tokens and use the secret key to verify tokens, to verify whether the values, which can be easily decoded, right, we saw that, were not changed along the way. So to do so, let's introduce a new property, private val secret key. Let's use keys match SHA-key4. And right here we will inject the value from, and this function requires us to send byte array. So what I will do, I will read the secret key, JWT properties, key, and use toByte array method. Before we go to implementing the functions, let's see how we can add the environment variable in IntelliJ IDEA. So let me open up application.yaml, copy the value of JWT key. Right here, there is the configuration of the application that we run. We can click on it and edit our configuration simply. So environment variables, and right here I can specify some JW key as a random value. With all of that said, and we saw how to add this to our project, we can add a function to our token service. Let me open up this class. And as the first one, I would like to add the generate function, which will take 3 arguments: user details, expiration date, and additional claims. So this will be quite generic function, which will be reusable and which we'll use for both later access and refresh tokens. Fun, generate user details from Spring Framework. This is the interface. The next one will be the expiration date, and this must be the date from Java util. Lastly, I would like to be able to pass additional claims as a map of string to any, and by default I would like this to be the empty map. So let's call it additional claims map string any value right here, and by default empty map. As a return, I would like to get a string value. So string equals. So in this place, we'll finally make use of the library that we imported. And what I would like to do here. Firstly, we must invoke the builder. So let's start with jwts.builder. Following, I would like to specify the claims. As you remember, claims are information about the entity that can use this token. So claims, excellent. The first one I would like to add will be the subject. I would like the subject to be the username, so that when we read the subject, we see who is the owner of the token, who should we validate against. .subject, and right here I would like to use user details, username. So at this point, let's see what exactly is user details. Let me click on it. As I mentioned previously, this interface comes from Spring Security and provides core user information. So we will use that to obtain information like password, username, or additional info like is account expired, non-logged, credentials non-expired, and at all whether this account is enabled. Let's get back to our token service and let's specify additional claims. So the next one will be issued at .issued at, and we will simply specify what time is now to this function. So date, let's use the constructor system dot current time millis. Excellent. Following, I would like to specify the expiration date, which is technically simply sent as a parameter when we invoke this function. So expiration, and let's specify the expiration date. Following, I would like to simply add the additional claims. So add additional claims. So whenever we would like to add something more, you're not limited to what you would like your JWT token to bring. So whenever we would like to add something more, we pass that to this function as the third parameter. With that done, we can hit end to finish building the claims, right? We started claims here, we specify what claims we would like to add, and later we build our token. The last thing we need to do here will be simply sign it with some key, and we already introduced key. So sign it, and with our secret key, and lastly invoke compact, which will return our JWT token as a string value. Excellent. At this point we have a function that we will be using later in our code base, but let's add additionally a bunch of functions that we will need. The first useful utility function will be a private function getAllClaims, which will take the string value, which will take the JWT token as a string value and extract claims for it. It will be used later to validate something. So private fun getAllClaims. As I mentioned, it will take token as a string, token string, and it will return claims from the JSON Web Token library. Let's open up the block, scroll down a bit, and firstly, let's introduce a parser. Val parser equals JWTS parser. The next one dot verify with. We will provide our secret key and build. Excellent. With that done, let's simply extract claims. So return parser parse signed claims token, and lastly payload. Ctrl+Alt+L. Again, our function will return all claims of our JWT token. With that done, I would like to add 3 additional functions which will be used later again in our code base. The first one will be extract email. Fun extract email. Again, this one will take token string value and will return a nullable string value because we can find or cannot find the email. Firstly, we'll invoke get all claims. We pass our token, and right here I would like to get the subject. So again, why subject to extract the email? Well, when we will be creating JWT tokens, we'll set the user details .username as the subject, right? And the username in our code base will be email because usually this is the unique value in applications. So later, when we ask for the subject, we'll get the user email. Similarly, I would like to add function isExpired, which will check whether our token is or is not expired. Fun isExpired. It will take a string value and will return a Boolean flag indicating whether the token is or is not expired. So again, firstly, get all claims. Let's pass the token. Following expiration to get the expiration date. And let's check whether this is before now. So before date, open up constructor, system dot current time millis. So if the expiration time from the token is before now, it means that this is expired. Pretty simple. Ctrl+Alt+L, let's format a bit. Lastly, I would like to add the isValid method, which will take the token and user details of our user authenticated in our application and verify whether the username matches the value from the token and whether the token is not expired. So fun isValid. Now token string value, user details of user details type, which we saw already in action, Boolean. Let's open up a block. And firstly, let's try to extract the email. So val email equals extract email. Let's specify the token that we got as a parameter to this function. And the token is valid if the username from user details matches the value from the email, and if the token is not expired. Return user details username equals email, and the token is not expired. Is expired, and let's pass the token. Ctrl+Alt+L, and let's quickly recap what we implemented here. So firstly, we introduced the instance of secret key, which will be used to generate new tokens and to sign the token when generating. Nextly, we have a generate function which will be used later to generate access tokens and refresh token in our application. We must pass the user details to set the subject of our token. We pass the expiration date, and we pass the additional claims, if any. By default, this is the empty map. Following, we have getAllClaims. So this function verifies the token, again using the secret key, to check whether the token was signed with the same key, and extracts the payload. When we have all claims, we can extract email, we can check whether this is expired, and that's what we do right here. And we expose a function which later will be used to simply verify, well, this token is valid, right? It is not expired, and the username of your user details matches the value of email from the token. And basically that's all for this video. We saw how to implement the TokenService and all the necessary logic that will be used later to generate and verify JWT tokens. And in the following lesson, I will show you how to implement custom user detail service. So without any further ado, let's get to the next lesson.